As promised, we're going to be spending multiple days on verifying trig identities. So today too, we're mostly going to be focusing on step 4 on this list, factoring and multiplying. Starting off with our first example, remember you want to pick the side that's more complex and get it into a simpler form. So when we look at this, both sides seem kind of complex, but that left-hand side has a quantity squared. So I'm going to start by writing out sine of x plus cosine of x times itself, because that's what it means to square something. And then I'm going to FOIL. We're going to try and get this simplified to what the left-hand side equals. So we have sine x times sine x, or sine squared of x, plus sine times cosine, plus cosine times sine. Because you can multiply in any order, I'm going to switch that around so it's a little bit more obvious that we have like terms. Plus, and finally we have cosine times cosine, or cosine squared. Now I recognize that sine squared plus cosine squared is one of the Pythagorean identities, so I'm going to rearrange that to write them next to each other. And as I mentioned, we've got those like terms, sine x times cosine x, and we have two of them, so we have 2 sine x cosine x. And finally, sine squared plus cosine squared is 1. That's one of our Pythagorean identities. So we match that right-hand side, 1 plus 2 sine x times cosine x. And then we're going to jump right into factoring. So looking at the left-hand side, it's obviously way more complex than the right-hand side. And I notice that both terms have a cosine x in common. So I'm going to factor out that cosine of x, leaving me with a 1, because when you take cosine divided by cosine, it equals 1. A lot of students are tempted to drop that when the GCF is one of the terms. So we have 1 minus sine squared x left in the parentheses, and we're trying to get that to equal the cosine cubed x. Next, I recognize that 1 minus sine squared. It looks like I might be able to rewrite that with the Pythagorean identity. So going off to the right here, one of our Pythagorean identities is sine squared. My pen is not liking ends today. Plus cosine squared equals 1. So if I subtract sine squared from both sides, I get 1 minus sine squared equals the cosine squared. So I can replace 1 minus sine squared with cosine squared. So that will give me cosine times cosine squared and of course cosine times cosine squared is cosine cubed. So we have verified our identity. On this example, the right-hand side is more complicated. Again, I'm seeing that tangent squared on both terms, so I'm going to factor out the tangent squared. So our first term, we're left with secant squared. The second term, that tangent squared divided by itself gives me 1, so we have secant squared minus 1. That is one of the Pythagorean identities, tangent squared equals secant squared minus 1, so I can replace that with tangent squared. And finally, multiplying tangent squared by tangent squared, we get tangent to the 4th.